right, AP Calculus. I hope everything's going well. We are in section 2.3. Hopefully you're keeping ahead of your homework. The big concept from this homework that I want to make sure you guys know is that the definition of something being continuous is the limit as x approaches a of f of x must equal f of a. If you can get that into your brain, that's the big bulk of whatever we're doing in this thing. So each one of these questions are leading you towards that. So does f of negative 1 exist? F of negative 1 is going to be right here. F of negative 1, yes, it does exist. F of negative 1 equals 0. Does the limit as x approaches negative 1 from the right-hand side? We look at this. From the right-hand side, it's getting closer and closer and closer to 0. So yes, it does exist. Does the limit as x approaches negative 1 from the right-hand side of f of x equal f of negative 1? And the limit as x approaches negative 1 from the right-hand side was also 0. Okay, so f of negative 1 is 0. The limit is also 0. So does the limit equal f of negative 1? Yes, it does. Therefore, is f continuous at x equals negative 1? Now, where this one will trick you up is the left side of this equation is nothing. There's nothing over here on the left of negative 1. But from wherever this function is defined, it is continuous. So this function is defined from negative 1 to 3. So is f continuous at x equals negative 1? Yes, it is. And the reason why is because the limit as x approaches negative 1 from the left-hand side is undefined. There's nothing over there. Actually, it would be 0 also. But there's nothing happening on that left-hand side. So endpoints can be continuous, and that's the key thing out of that one. Find each point of discontinuity, which are removable and which are non-removable. So this one, kind of quick, easier. Just graph it. So we got 3 minus x. That means the slope is negative 1. It crosses through at 3. 1, 2, 3. The slope is negative 1, so down 1, down 1. We're going to get a line that looks like this. Okay, but notice this is only from x when x is less than 2. So here at 2, we're using that graph. So I'll go ahead and grab another color so that you guys can see. Let's graph this other equation too. This one, it crosses through at 1, and then it has a slope of 1/2. So crosses through at 1, rises 1, runs 2. So it gives us rises 1, runs 2, rises. It gives us a equation that looks like this. So if we were graphing this piecewise function, this graph would be this piece right here until 2, and then at 2 is an open circle because this is open right there. And then this one right here would also be an open circle, and it would go like this. Okay, so we have discontinuity right there at x equals 2, and you can see that 3 minus 2 is 1. 2 divided by 2 is 1 plus 1 is 2. So they're not even at the same exact spot. So we don't have any removable discontinuity. Removable can be replaced with just replacing one dot. We have a non-removable because there's this jump right here. If we looked at this graph, it's kind of hard to see. If we looked at this graph without the red in there, it would come down like that, and then it would go up like that. So anytime you have a jump discontinuity like that, that's going to give you a non-removable discontinuity. So the next question says, on which intervals is f of x equals 1 over the square root of x not continuous? Now, this is a great question because it's a multiple choice. What I want you guys to do is I want you to really work hard on doing these multiple choice questions. If you just take a guess and just put an answer, yeah, you're going to get your homework done, but you're not going to see the importance of what these questions are asking. So I would look at this equation, I would graph it real quick, and I would just say 1 divided by the square root of x. Okay, graph it. And we look at this. On which interval is f of x equal 1 over square root of x not continuous? So the first answer is 0 to infinity. Looks continuous from 0 to infinity. Closed at 0. Maybe I have this question written down wrong. So let's open it up real quick and see what it says. (2.3) number 56. Oops, this is on which of the following intervals is f of x equals 1 over the square root of x not continuous? Okay, so from 0 to infinity, it is continuous. From 0 close, see how this one's closed right here? If we plug in a 0 into here, we get 1 divided by 0, which is undefined. From 0 to 2, it's open at 0, so that means you don't have to plug in the 0. Open at 2, so you don't have to plug in the 2, but everywhere in between 0 and 2, it is continuous. Same with 1 to 2 and 1 to infinity. So our answer is going to be B, because you can't include 0 on this function. All right, guys. I will see you tomorrow in class. Thank you again for watching these. I hope they're helping you.